Hi, and welcome to another exciting episode of the 6502 Show. Well, today we're going to use this platform for a 6800 edition because I have found a near forgotten tiny basic that came from down under. So we're going to try to get it running again on my homemade 6802 machine and put it through a few paces and see what it can do after all these years.
Hey kids, it's the 6502 Show.
I found this thing while searching for something else on a random website. It was actually, I think, a Google Sites page that hadn't been touched in like 10 years or something. But the person had posted the source code for this thing called DATUM Integer BASIC. And apparently it was meant for the DATUM 6802 trainer board, which was part of a package put together by some institute in Australia somewhere, Adelaide, I believe. It's kind of odd because the BASIC wasn't built until probably 1981, published in 1982. So that means that stuff like MicroBasic Plus by TSC and Southwest Technical's BASIC, written by Bob Wiederwick, those had both been out for 5 years, as well as Pittman's 6800 BASIC. So, why? I don't know. Nakamozu BASIC had been around for 3 years by then, Dendai as well, from Japan. So, I don't know why they did it. Perhaps it was an academic exercise, since this was tied to teaching and training. The first thing I did was I took the hex file that had been provided on that Google Sites website and I ran it through F9 disassembler. So I got some raw code out and just no labels, really, just numbers for labels and no comments, of course. And then the reconstruction process began. All right, so here's the process. After imperfectly copying from the PDF, pasted into my text document and just started cleaning stuff up to make it look as much like the original as possible. You know, sometimes an asterisk doesn't come across, or an O is a zero, but it's easy enough to, just put some spaces and tabs and put out, or take out rather, some other crap that doesn't belong there, line it up. So that looks good, spell checked. Once we get that done, then we can work on the code itself. Get stuff lined up here, and we'll just start checking things. Store xxtemp, JSR, check stack, load user pointer. Here we've got a label that needs to be replaced, result +1. And we'll keep checking. Store A, dex, load A, store A, dex. Here, okay, now down here, we're going to make these look like the code that was printed in the original PDF. So I'll just take out that number. And there's a label that needs to go, so we'll hunt for those, 9 of those. So we'll just replace them all with the appropriate label, PRBI01. And replace all. And away we go, we're done with that. And so it continues. Take this 2D out, and we'll put in a minus sign. And we'll go from there. Once I had the mnemonics and the operands in, it was time to tackle the comments. This was tedious as all heck. One at a time, checking for typos, fixing typos. Could I have sent this to an AI agent and said, you do it? Well, yeah. And maybe I'm an idiot for not doing that, but, what else do I have to do all day? So, did this. In a way, it's kind of meditative. You just work at things slowly, one line at a time, and it's interesting. You can find things as you go along. It's like, I would have missed that otherwise, and I wouldn't have known what was going on, because I'm staring at this stuff, for sometimes hours. But in the end, we got it done and came up with a source file that would compile. Wow, I sounded like that YouTuber guy, Chef John.
Of course, that's totally up to you. You are the Mad Hatter of your Banya Kauda platter.
Source code file that will compile. All right, let's take a look at this thing now that we've got it running. As you can see here, here's a summary. Very few commands, minimal amount of statements, a single function, peak. Math operators, pretty typical for an integer basic. There is no precedence in the order of operation. Parentheses will take the only precedence. So you got to set it up yourself. Otherwise, it's straight left or right. Logical operators cannot be used in if statements, so they're not conditional. They don't factor into that at all. And your relational operators, you got three. You got equals, less than, greater than. That's what you have. Features down at the bottom, uppercase, range of integers, okay, fine. Line numbers, fine. It's a BCD system, so that makes sense. Variables, just like most other tiny basics. And 72 line input buffer. The big thing that's missing is there in functions. There is no random function. So there you are. And you'll notice another interesting weirdo thing. Cold start address 2800, warm start 2803. 28? Like, why? Strange memory map, my friends. They didn't bother to hook up A15. It's just ignored. So you've got all kinds of repeating images and what would be memory. It's just going to keep accessing. It resets. It wants to look at FFFE. Well, 7FFE will work just as well. So the whole thing is only set up for 32K, and they did some weird stuff. But we'll leave that for another video another time. Suffice it to say, that's where it is. Your user memory in the original data machine was from hex 1000 to 2000. So 4K is what you had. For my installation, I just backed it up to 0100, bought myself another 3.78K. But again, just because there was nothing that RAM was doing. Okay, here we have the good old-fashioned Rugg-Feldman benchmarks from the June 1977 edition of Kilobaud magazine. And there's a Wikipedia page right there for you to check out if you wish. The benchmarks are pretty simple stuff, and they progress as you go along. Here, can it just do a little loop for number one? And we're going to print our start and ending time so that I've got something to click my stopwatch with. And then we're going to add in a little bit of math, and then we're going to add in a little bit more math. And then instead of variables, we're going to use constants, so that should take a little longer. And here we're going to add a subroutine for benchmark 5. And then we've got a subroutine that actually, let's see, what does it do? Oh, benchmark 6, we're going to dimension a variable. Now, DATUM Integer BASIC doesn't have a dimension statement, so we'll just clear out 5 spaces of memory with a poking 0 and let that stand. Yeah, close enough. And then we've got the full-on Monty benchmark down there, number 7, for our final test. All right, let's take a look at the results and see how this stuff stacked up. And here are the results. Not too surprising or shocking. In some cases, a little bit. I've marked DATUM Integer BASIC as DIB. It's on the bottom compared to some other tiny basics, all 4K and under. And it performed a little bit better here than Micro Basic Plus from TSC. And it's really not fair. Pittman's Tiny Basic doesn't have 4 next loops, so, you have to fudge it, and it's not an accurate result. But as you can see, Dendai and Nakamozu are far and away faster than anything else. Here, DATUM Integer did okay, a little bit better than Micro Basic Plus on the second bench. But as we move along, things start getting a little bit tighter, and eventually we'll start diverging. Bench 3, about the same result for Micro Basic Plus and DATUM. Dendai did really well. Fell behind Micro Basic Plus here on the 4th benchmark. On the 5th benchmark, also behind. On the 6th, well, not so much, let's see, 10 seconds, not nearly as bad as benchmark number 5 was. And down here on bench 7, it actually did quite a bit better than Micro Basic Plus, but still, 4 times slower than Nakamozu Tiny Basic. And we can't do good old-fashioned testing without running Sierpinski's carpet. Here we go. This is a slightly modified version of the Micro Basic Plus one, so we can get some comparison here. And the carpet's starting to print, so I will move ahead towards the end of the show. And there you have it. It looks like the DATUM Integer BASIC is about 1/3 faster than Micro Basic Plus. But, there are the trade-offs. We've been discussing them for minutes. So, that's that. I would show you some demos of this thing running some games, but it can't do it. There's no random function, so it's probably not going to run any game at all. And just for giggles and other bodily functions, I thought, hey, let's just see if we can print a Mandelbrot set with this thing. Now, I've been able to do this with Nakamozu Basic, and it looks pretty simple enough here, but when trying to get DATUM Integer, it turned into this monstrosity. Huge piles of if-then, followed by individual print just a character because it doesn't know what character to print, so you have to tell it up here with this here formula down here because you can't do anything with computed Go subs. And it says so right here. You're going to go to a line number, and that's what you're going to do. Well, I guess the only thing this proves is that where there's a will, there's a way. Yes, there you have it indeed. I guess the bottom line is this thing useful? Well, no. But another part of the bottom line is it historically significant? And I would say absolutely yes. Quite a few thousand of these DATUM kits were sold, and I'm sure that there were a lot of people who used it, or at least use it to learn how to do things, build high-level languages, and get a start in coding in that vein. So for that, it's useful, and it's worth saving. So I'll get this finished up, editable source code, and some other documentation that I found. I'll get it up to BitSavers as well as archive.org. As far as I'm concerned, Nakamozu Basic, Tiny Basic rather, is still the champ for small 6800 machines. The thing is fast. And, as far as performance goes, this thing, DATUM Integer BASIC, probably the worst of the lot. I suggest you just use Micro Basic Plus if you want to go minimal. Thanks for watching the show. I had a blast putting it together. It was fun reconstructing, something of historical value. So until I put another video together at some time in the future, you all take care.